This is section 3.9, step functions. That guy's going up steps. Here we go. Objective and what's the point? We are going to introduce and explore the important class of functions called step functions. And we're going to evaluate them. We're going to model with them and look at their graphs. Many real-life situations are modeled by step function. You're going to see this again next year. And you've encountered it before, but you have not modeled with this certain function. But it is important that you understand it so that you can see the mathematical meaning behind it. Okay, step function. It is a piecewise function that looks like a series of steps. And if you look on page 203 in your book, you can see what I'm talking about. On page 203, there is a graph that they gave you to show what it looks like. I'll kind of give you a sketch here. It kind of looks like this. Whoop, whoop, whoop. Okay, it's like steps, like you could draw a guy walking up them. Okay, it is a function still. It's not continuous, but it is definitely a function because it passes the vertical line test, because those open circles mean nothing is happening here. So the only place that it could hit twice would be right here if you see this vertical line. But one is open and one is closed, so it is a function still. Okay, the floor function is a common step function. It's also called the round down function or greatest integer function. Okay, and I think this is probably the most common. In calculator language, it's called the int function. It looks like this. Floor function, see there's a little floor here. It's like a half brace. And we round things down when we use this one. The ceiling function is also common, but I wouldn't think it is as common. Maybe with billing it's more common. But it's called the rounding up function also, or the least integer, and it has a ceiling. Oops. Also half of a brace there. Is that a brace? A bracket? I don't know. A square bracket. That's what it is. So it's half of a bracket. Okay, so we're going to evaluate these. Basically, when you see these, all you have to do is round appropriately. So this is a floor, so it's telling you to round down to the floor. So how do I round 4 3/4 down? It rounds down to 4. Okay? 4 pi. Well, 4 pi is the same thing as 12 and some change. 12 point something. It doesn't matter what the point something is, because when I round it down, it's just going to round straight to 12. Negative 5.87. Be careful when I round negative 5.87 down. Think of a number line. Negative 4, negative 5, negative 6. When I round it down, I'm going to go to negative 6. 7 minus 0.5, ceiling, round up. That's 6.5. Round that one up, and I get 7. That's one way you could do it. The other way you could do it, no, not really. I was going to say you could round that up first, but if that was the case, then you would have 7. No 7 here. 7 rounded up is 7 minus 1, and that's 6. So don't do it that way. Make sure you do the calculation first, because there are parentheses here. 7 minus 0.5 is 6.5. Round it up to 7. Okay. Oh, I didn't want that to happen. Okay, refer to example 4 on page 206. On page 206, they are talking about a way that companies bill in cell phones or long distance companies, which that's the thing in the past for you guys. For you guys, it's all about cell phones now. But what happens is, for the specific company, that they'll have 2-minute billing increments. They don't recognize minutes as singles. They look at them in pairs, okay? So if it's a part of a minute, you round it up to the next even one. They do this so that they can charge you more money. Okay, so a 3-minute phone call, they would bill you for 4 minutes. Okay, so Call Me Often Phone Card Company, that's the company, charges 3 cents per minute with a 2-minute billing increment. What does an 18-minute, 10-second phone call cost? Well, 18 minutes, 10 seconds. You can't just get rid of the seconds. We're going to have to round it up. Where will it round to the next even number? So it's going to round to 20 minutes. How much is it per minute? Times the 0.03 cents. That's going to be 60 cents. Okay? So that's an example of a 2-minute billing increment. Okay, this is number 14 that you'll see on your homework tonight. A used car salesman is paid $3.50 per week plus a commission of $100 for each $1,500 in sales during the week. And this is kind of an accurate thing that could happen in real life. A lot of people do get paid on commission, not as much as in years past, because now that's not a very good job because of the current economy. But car salesmen are notorious for being paid on commission. That's why they say they're pushy, because they're trying hard to make money. Okay? So they want to find the salesperson's salary during a week, so it's 1 week, in which he or she has $3,500 in sales. So what are we going to do? Well, it's going to be 1 week, so you definitely get the $350. Then you need to figure out what their commission is. Well, every $1,500 is $100. So plus, what are we going to do? 3,500 divided by 1,500. Some people would do it that way, 3,500 divided by 1,500. I personally would do it in my brain. I would say 1,500, that's 3,000, so I got $200 extra. Because I'm going to take this, which is 3,500 divided by 1,500, and we get like 2 1/3. So it's just 2. 2 times the $100 for each $1,500, so $350 plus $200 is $550. Because that extra $500 doesn't even mean anything. Now, to write the equation is harder. Usually when you write equations involving step functions, I'm going to recommend that you do a test example first to see what I'm doing each time. Because otherwise, you're like, what would I do if it was 4,000? I divide out. That division is important. They want to know a weekly earning and for $E. So how much is he going to earn? He's going to earn, well, it's definitely going to be $350 at least. Then it will depend on how much he sells. What will I do? I'll take how much he sells. I'll divide it by 1,500. Okay, and we are going to round up or round down here. I get rid of the decimal. If I get rid of the decimal, I'm rounding it down. And then I'm going to take that times how much? $100 each time. So is it possible for the salesperson to earn exactly $1,000? Well, let's think about it. This part of the equation right here is going to end in zeros. I'm going to get 100. I could earn $100 in commission, $200 in commission, $300 in commission, $400 in commission, and so on. This is going to be in the hundreds. When I add that $350 to my commission, I'm always going to have that $50 in my paycheck. $350 plus $500, $350 plus $800. No matter what, I'm going to have this $50. So is it possible for him to earn exactly $1,000 a week? The answer is no, because you are always adding the $350 to your commission, which is in the hundreds. You are always adding $350 to your commission. That's how you spell commission, which is in the 100s. Okay. Last thing, we're going to graph this. When you graph a step function, you know kind of what it's supposed to look like. You know it's going to look like steps. The only thing that is different about step functions is where the solid dot is and where the open dot is. Sometimes it's like this, and sometimes it's like this. These are two different ones. Sometimes it goes solid, open, solid, open. Sometimes it goes open, solid, open, solid. So we need to figure out what to do. So the best advice I can give you is to make a T-table. Okay. Plug in some integers first. If I have 0, 0 round up, still 0. Because you're just rounding it to the nearest integer. It just means drop the decimal. Okay. If I have 1, 1 round up, still 1. So 1, 1. Okay, one more. 2, round up is 2. Okay. So you see how the solid dots are going to go. They're going to go right on the y equals x line. Okay, now what happens at the decimals? Are you ready for this? I'll continue here. If I have 0.5, 0.5 round up is 1. So 0.5 up to 1. This is still on my line here. 0.1 rounds up to 1. 0.1 rounds up to 1. So you can see that the bar is supposed to go this way. It has to say a function still, so that's where my open circle is going to go. That's usually enough for me to figure out which way the bars go, but you can do another one if you need to. 1.5 rounds up to 2. 1.5 up to 2. Yep, this is the way the bar is going to go. Then it'll be open circle. So it's going this way, open circle. To the left, open circle. To the left, open circle. That's what the graph looks like. I really encourage you to use a t-table when graphing. That is my advice when that shows up to you. Okay, that's it. I'll give you your homework assignment tomorrow in Don't Let This Be You. Don't follow on the steps. Okay, see ya. Bye.